My name is Rob Barnes. I am a Senior Developer Advocate at HashiCorp, primarily focused on the secure product line. So continuing on from where Megan left off, essentially when we think about zero trust at HashiCorp, we think about identity-driven controls. And like Megan said, we break it down into 4 different subcomponents. So we have the machine authentication and authorization, we have machine-to-machine access, and we also have human-to-machine access, as well as human authentication and authorization. And in this part of the talk, I'm going to focus mainly on the machine authentication and authorization. And for that, we have HashiCorp Vault. So we'll start with Vault. And in terms of Vault's role in this piece of the zero trust identity-driven controls puzzle, Vault is a number of different things, depending on how you use it. Megan kind of alluded to this, that Vault is essentially a secrets management platform. It's a place where you can store credentials or secrets. It's also what we more fondly refer to as an identity broker. And I'll explain as I go through the demo what I mean by that. But essentially, to kind of give you the high-level pitch on that, it's brokering identity on behalf of your target platforms, whether that's databases or clouds or whatever it is. Right? And then Vault also does some other things as well. So it offers encryption as a service. So rather than having to roll your own cryptographic solutions and manage your own keys and manage the governance of those keys and so on and so forth, Vault is a one-stop shop that allows you to take care of these things as well. So to kind of bring that to life, we've got a very simplistic application that we're going to look at today. Right? It's a profile API. Right? And this profile API is quite simple. It takes some details from whoever the end user is, and it needs to place that inside the database. There's nothing complicated about it at all. Right? So in this kind of application topology where you have the API and you have a database, there is one challenge here, which is that the profile API is going to need credentials for the database, right? And how are we going to do that? How can Vault come in and help our profile API achieve that goal? Essentially, the way that Vault works, this is a 2-step process, right? So there's an authentication process, and then there's a process of generating credentials. But let's talk about the authentication process. So Vault, if we look at the domain model of Vault, it has this concept of auth methods, right? So an auth method is a mechanism which allows us to authenticate to Vault. It's quite simple. Now, how our applications, or even people for that matter, can authenticate, it's entirely up to you. We have a series of auth methods, whether it's OIDC to bring in your identity providers externally, if you want to use Okta, if you want to use Active Directory, GitHub, whatever it is you want to use, you can configure it so that instead of storing the identities on Vault itself, you can keep your identities managed in that central place, your identity provider, and we can literally log into those servers there and verify the identities of those people or machines that are trying to authenticate. Right? So we have several different auth methods available. I've forgotten the exact number that we support, but essentially, if you have an identity provider you're using, the chances are we have a auth method for that. Once our applications have authenticated to Vault, we're now in a situation where we want to generate these credentials. So in our application, we were talking about authenticating to a database. We have database secrets engines for all of the popular flavors. We also have things like the transit secrets engine, which is more to do with the cryptography as a service. We have secrets engines for all the major clouds, PKI to manage your PKI centrally as well. So those are essentially the 2 steps. We have the concept of auth methods and secrets engines. So you want to authenticate, and once you're in, then the secrets engines are going to take care of delivering the actual piece of value to your engineering function. So if we look specifically at the demo that we're going to be doing today, just for the sake of the demo and to make my life a bit easier, I chose an auth method that we call user pass, which is essentially username and password, right? If you're on Kubernetes, you can use a Kubernetes auth method, for example, that will use a Kubernetes service account. If you're on Azure, for example, you could use the managed identities which are in Azure, and we can authenticate with that to get into Vault. I've decided to use UserPass just because it made my life easier just for demo purposes. And as we said, we're going to be authenticating to a database. So we're going to use the database secrets engine, and there are specific plugins for the database secrets engine. We're going to be using a Postgres one because our database is a Postgres database. So if we have a look at the workflow of how this is going to operate under the hood, right? So the first step is our application is going to need to authenticate to Vault. So we've just talked about how you can do that using the different auth methods. Once authenticated, Vault will then go to our target platform, right? So in this case, it's our Postgres database, and it will say, hey, our profiles API wants a credential. Can I create a credential? And it will literally create a credential within that target platform, in this case, the Postgres database. It'll create a username, it'll create a password. And once it's done that, then the third step is it will return it to the profile API, right? Now, what's nice about our workflow there is the credential didn't exist before the API needed it. Vault then brokers that on behalf of the database itself. Normally, there is a time to live associated with that credential. So you could say that this credential is valid for 1 hour. And Vault is going to manage the life cycle of that credential. So after 1 hour, what it would do is it would go back to the database and say, hey, do you remember those credentials that you created for me? Can you delete them, please? And it would delete that. So what that does is it stops this idea of secrets being sprawled everywhere. We don't have generated credentials stored in different places. We don't have the challenge of if we need to rotate credentials, well, how many credentials are we talking about? Where are they stored? Instead, it's all managed centrally, and Vault is kind of the gateway to this entire secrets management path. So the way that this is set up at the moment is, Megan mentioned that we have a HashiCorp Cloud Platform. This is a managed service provider, essentially. So instead of managing your own Vault in this instance, we will manage it for you. Your end of the responsibility, the shared responsibility model, is essentially configuring Vault as per your application and business requirements and administering it according to your identity and access management protocols internally, which will differ from company to company. So essentially, we have HashiCorp Cloud Platform. What we do inside that is we create something called a HashiCorp Virtual Network, which is no different to a VPC or a virtual network in Azure. The flavor that we've got here is in Azure. It doesn't really matter which cloud it's in. And then we have a private virtual network, which is our own, which we roll in our own Azure subscription. And we set up VNet peering between the two. So this is how we can have workloads which are in a private subnet, which are not normally accessible by the internet. But Vault is still able to contact all of these services here because it's got that private VNet peering between the two. All right, so the demo is going to be a little bit different than that. It's made my life a bit easier just to roll with the application on my laptop itself. But everything else is hosted in the cloud. So the database is cloud managed. Vault is running on a HashiCorp Cloud Platform. But essentially, this is the architecture. You could, if you want, run your own Vault. You can manage the lifecycle of Vault itself and operating system patching and upgrades and so on and so forth. But HashiCorp Cloud Platform does make our lives a bit easier in this sense. So now you've kind of got the overall picture. I'm going to flip my screen so that I can show you my code editor.
While you're flipping your screen, I have a quick question. How long do the credentials last? Is it for the duration of the engagement, or does it do they have to authenticate each and every single time, or does it last for a long period of time? I just want to know the timeout parameters for it.
That's a fantastic question. So how long does the credential last? That's entirely up to you. You specify what the TTL is. It can be a minute, it can be 10 minutes, it can be 30 days, it's whatever you want. You specify that. In terms of when the application is connected to the target platform, does it have to authenticate every single time to Vault? Well, what we're talking about here is kind of application development patterns, right? So that is one way of doing it. It's probably not the most resource efficient way of doing things. I've seen people roll solutions where they have a separate service which takes care of ensuring that the credential is always live and your application just goes to a specific location and trusts that whatever details are inside there are the most up to date. So you have a separate service which is interacting with Vault. We also have Vault Agent as well, which is like a client-side kind of part of the application where you can use that to authenticate and grab credentials and store it in a sink, be it a file or an environment variable. That's entirely up to you, and that can take care of the whole automatic authentication piece. But really what you're delving into there is about patterns, and the patterns are pretty much limitless. It's kind of what works for your organization and your applications.
Thank you. Because I was just curious about if I'm making a one-off API call versus 50,000 API calls, and that's a lot, to authenticate, even, whether it's 10 minutes or every hour.
Exactly that. So here, what I've done is I've used Bash. I wasn't sure what programming languages people were familiar with. It just made sense just to write this example purely in Bash so that everyone can see. So this is our profiles API, and it's simple. It's going to take some user input, and it's going to write all that information into a database, right? So if we just have a quick look through the code, you can see that there's already some issues here. We have the Postgres username in the file, which is something we want to avoid. We also have password, which, because we're on a live stream, I wanted to make sure that no one gets in, so I've put that as an environment variable. But nonetheless, these things have their own inherent risks. And then we're just asking for a series of questions. So it's just some name details, email address, username, and password, right? And once we get all that information, we're just making a couple of calls to our Postgres database. We're just going to make sure that the table exists. If it doesn't, it will create it. And then it's going to write that as a row into our database. So there's nothing too fancy about it, right? So if I just literally just run this application just to kind of show you exactly what's going on. So if I just boost the size of this screen a little bit and run this application. So it's asking for a name. We'll call the name first name security, and surname is going to be field-day. And the email address is going to be security@fieldday.com. I want to choose a username. So the username will be security-fieldday. And we'll create a password, which I'm not going to tell you because I'm super secure, but you can see it on my screen anyway. Okay, and it creates that user profile. And we can see here, it's created that, it's dumped it into the database, and there you go. You can see that we have, I'll just move this out of the way so I can see. You can see the first name, you can see the surname, you can see the email address, and you can see the password, right? So the first challenge we've got here, as we already know, is we're using hard-coded, long-lived credentials to authenticate to the database to do these things, right? That's a problem for the reasons already explained. So we're going to refactor the application to take care of that. But the second problem we have here is the password is not encrypted, right? So we can see this information here. And the email address is known as personally identifiable information. Again, this is stuff that we need to take steps as organizations to protect these things. If you're found to have a data breach and you haven't taken steps to protect PII, then it can have very detrimental consequences for your organization. So those are the two main problems that we're trying to solve within this application here, right? Okay, cool. So I'll just clear this screen. So I didn't trust myself to refactor this live, so I actually refactored it ahead of time. So we'll have a look at the refactored code and see the difference. Here we go. So just move this out of the way. Okay, so we have some of the similar details, but instead we don't have the Postgres username or password there as our variables anymore. And if we kind of scroll down, same sort of things, but it's taking the same inputs. But now this is where our refactor comes in. Firstly, we need to authenticate to Vault, right? So like I said, I'm using userpass, which is a username and password combination that's just stored as environment variables. The way you could do it, if you're hosting this in Azure, is you have managed identities. Azure, for example, gives you a metadata service where you can make API calls within your infrastructure. and it's only accessible from within that infrastructure. So I can't remotely execute this. And then it can take this metadata and then build a picture and then give those details to Vault. Vault will then go to Azure and say, hey, is this a valid identity? Vault says yes. And then what happens is it will exchange that for a Vault token, which is the core construct of Vault identities. No matter how you authenticate with Vault, it always results in a Vault token. That's how you log in. You have all the policies associated with that. So what you're authorized to do is all associated with that Vault token. So here, all we're doing is we're just creating a payload. We're making API calls. This is one way to interface with Vault. You can do it via API. We also have a CLI. And we have a user interface, which I'll show you shortly. And we're making just this API call. We're using curl. And we're literally saying, here is the username and password. If it's valid, give me back a Vault token, right? So it will store that in this environment variable here. And then now we're authenticated. We're now making another API call to Vault. This is very verbose, the way I've done this. And I've done this because I'm trying to show you the workflow of what's going on behind the scenes. There are definitely better, more performant ways to do that, but I don't want to abstract away what's going on under the hood because I want you to understand what's involved, right? So now we're making the second API call to Vault to say, can I have some credentials for that database, right? And just using that same workflow that I showed in the diagram before, Vault is going to create those credentials with a short-lived TTL, and it's going to provide it back to our application, right? So now we have those credentials. The next thing is we want to encrypt those sensitive values that our application is handling, right? So the first thing we want to encrypt is the email address. So when we get that information from the user, we are basically base64 encoding that value. The way that the encryption works in Vault is it uses something called a transit secrets engine. And a requirement for it to encrypt anything is for any data to be base64 encoded. So it will base64 encode that, and then we create a JSON payload, and we make another API call to it to say, can you use this cryptographic key? So we've got the secrets engine, and in that secrets engine, we've created a cryptographic key for this application. We call it demo app. And we want to use that cryptographic key to encrypt this piece of data. And we do the same thing again for the password. We want to encrypt the password. It's the exact same workflow.
So question.
Yes.
So you've created a credential for this application.
I have.
Is there a way to hash the application such that if you tried to use application A's credential in application B, that the Vault will go, oh, but you're not application B because we ran some sort of integrity check or some sort of a challenge or something, so that you could kind of be like, are you the application that you're pretending to be using this credential asking me to give you secrets?
So your question there is centered around this idea of attestation, right? You want to attest to the identity. So yes, there is a way. It depends on the secrets engine you're using, and it depends on what you trust, essentially, right? So the example I gave with the Azure auth method, for example, is your attestation. You would trust Azure. You would trust that when you assign an Azure identity to a VM, for example, that any information that you get from that VM's metadata service, that's what you're trusting. You give that to Vault, and then Vault will then authenticate with that. No other application is going to have access to those metadata details unless you've architected it in a really bad way. But essentially, they're not going to be able to remotely get those details. So that's your attestation there. We go to a Kubernetes example, your service account. As long as you have architected your Kubernetes setup in a pragmatic way, then that can become your attestation as well. If you're sharing service accounts amongst loads of different things, then that's not really any good. But if you have a service account per workload or per service, then essentially you can then trust that if that's how your organization views things, and that will be your attestation there. With the method we're using in this, that attestation doesn't really exist. Like I say, I only chose this just because building 3 demos, it made my life a bit easier just to choose that. But
well, no, I mean, I totally get it. I'll be honest. I mean, I write scripts, bad ones, that use API keys and whatnot, and I am at the moment trying to migrate to storing those API keys in a HashiVault as opposed to just another file in my Python directory, which makes people nervous. But when I do that, I was thinking that it's like, okay, well, ideally, it would be great if I could somehow MD5 the script when it was done and say, okay, let's make sure that if someone changes this script or somehow, if I want to say this script is allowed to do the following things, how do I make it so that somebody else can't grab those
sure.
credentials? That's just something
Yeah.
I was.
So I can say from now that exact piece of functionality you're talking about for that type of use case isn't something that exists at the moment. You're not the first person that has mentioned something like that to me. So it's something that has played on my mind a lot, and it's things that I've spoken to other people about. But currently, as things stand, that's not a form of attestation that we support at the moment. Okay, so we've walked through the script. It's pretty much doing the same things now. It's just going to make the database calls here. So if I run that now, so this one is called Secure Demo App, and we'll take some details. So my nickname is actually Bobby. Actually, let's not use that just in case I've used that in my test. Can someone give me their name, please?
Brian.
Brian. Is that with an I or a Y?
I'm just about to do the same to you.
It's an I.
It's with an I. Okay, cool.
It's with an I, huh?
Let's register Brian.
The right way to spell it.
And your name is Brian Secure, just for your own identity's sake.
Good, because I can't spell Knutson.
Okay, and your email address is going to be briansecure@fieldday.com. And your username is going to be secure, because that's what we want to be, don't we? Right?
Right.
Okay. Then we'll choose a password, which is super secure. You're never going to crack this one here, which is password of a lower P, right? And you can see just in the output there that it's making those series of API calls. And I'll just boost the size of the screen so we can see the output. And this is where it gets good, right? So we can see that your username is bsecure. We can see your first name is Brian. We can see your surname is secure. Now, for your email address, instead of having the actual email address, now what we have is some ciphertext, right? And the way that Vault does that is it prefixes the ciphertext with the word Vault. Where it says V1, that's the version of your cryptographic key, right? I'll talk about that in a second, right? And then following the V1, we have the actual ciphertext itself. So that is your information encrypted. And we have done the same for the password. Now, if we talk about the V1 piece, now, essentially, one of the benefits of letting Vault do the cryptography for you is if your organization's security posture, for example, says that you need to rotate your cryptographic keys every 30 days or something like that, well, you've rotated it, but how do we know what version of the key we need to decrypt that data with, right? So this is version 1 of the key. If we were to rotate it then and we encrypt data with that, it would be V2. Then what we can do is anything that's V1, we can take that and we can make another API call to Vault to rewrap it, which will basically decrypt it and then re-encrypt it using a new version of a key. So we have the API support for all of this. And the thing that's nice about this entire workflow is that everything is built with the API from the ground up. Yeah? So even when you use the CLI under the hood, it's using the API as well, which is really friendly for us as engineers and developers, right? In terms of how we've built this application, I will stress again, this is extremely verbose just to paint a picture for you. I know you're not going to build your applications like this. I just want you to understand what's happening underneath the hood.
Don't underestimate us.
And that's that. So that's essentially, so if we just kind of recap from the Vault side of things, so what we've done now is we've got some credentials from Vault for that database. And we've authenticated, we've got some credentials from Vault, and then what we've done is we've used the transit secrets engine in Vault to encrypt the sensitive data in that before routing it to our database. In terms of the token that was used to do that, it has policies that allows us to request that database credential. It also has credentials to allow us to encrypt using that key and only that key. It does not allow us to decrypt using that key or any other key. So if we had a second API, which job was to decrypt that data and do something else with it, then you can assign very tightly scoped permissions so that it can only do the things it needs to do.
I just want to make sure I understand how these pieces all get together. A Vault is acting as an identity broker, sort of as you guys mentioned.
Mm-hmm.
But it's not acting as like a transaction broker, right? So when I want to talk to my destination system, I'm not actually talking through Vault. It's the application client, I guess, talking to the the real destination.
Is your question about network communication between the two components? Is that kind of what the basis?
Yeah. So it's not being proxied through Vault. Right?
No.
When it comes to past, credential rotations.
Yes.
So like this gets really interesting, especially when you have, software that is using this to, especially for like databases, as kind of this was demoed. If I go out and I get these credentials, those things have to be accurate.
Yes.
And so, setting up rotations gets really complicated because there's a period of time where there's a change between these. So what's kind of the design pattern for supporting that?
Excellent question, and by far one of the troubles that plague developers the most, I think, when it comes to secrets management. So the easy solution to that is depending on what you use. So if you're using like Java, for example, and you're using the Spring Boot framework, that has a really nice, neat feature inside it, which allows you to gracefully kind of shut down the connections. It will drain the connections while it will reload and then spin new connections up using the rotated thing. So that exists nice out of the box with the Spring Boot framework. Outside of that, you're going to have to roll a solution that implements the same kind of thing. Now, whilst I can't say too much on this is a conversation internally we have a lot, and we are looking at ways to try and bring that same kind of functionality across all programming languages without you having to roll your own solution. But that is a very excellent question. It is a challenge that we need to solve, I think.
Is the like create then delete and rotate inside of your connection logic one kind of way to do that? It's where I create a new set of credentials, rotate, migrate to that, the new connections to that, while the others go into some sort of timeout.
That's exactly what we want to do. We want to create this new credential, and we want to spin any new connections with that credential. We want to stop any new connections using the old credential, and we want to start draining and gracefully shutting down the existing ones. So there is that kind of transition period, but your application should effectively not really notice any downtime because these things are being handled using the new connections and the new credentials. So if you are going to roll your own solution right now, that's essentially what you want to achieve, I think. It's definitely how the Spring Boot framework is operating in terms of the SDK that we have for it, which I'll just quickly reiterate. So we have the API, we have a CLI, and we have, I think it's 2 supported SDKs, which is the Golang SDK and the Ruby SDK, and a bunch of community SDKs out there. And the Spring Boot one that I talk about is a community supported one, but it's in use by some really big players in the game. And it's very well backed at the moment. So yeah, definitely check those out. If you're using Vault, these SDKs can make your life a bit easier because they think about these problems and roll it into the framework.
So in the event that we have static code that we don't control at the client, can we dumb that down a little bit and say, okay, well, we're not going to use rotating credentials because we can't put that into the client, but still provide identity-based access to the database itself?
Kind of, right? Okay, so just to make sure I understand your question correctly, your application doesn't have the bandwidth to be able to deal with secrets rotating. So what is more healthy for your application is something a bit more long-lived. Is that right?
Sorry?
What's more healthy for your application is a credential that's more long-lived. Is that kind of what you're getting?
Yeah, or you just don't have the ability to change the credentials in the client, and so you want to forego the credential rotation. Like it's not ideal, but it's kind of the reality.
It's the reality of a lot of people. Totally understood.
Situations. Can we say, okay, well, we're going to do the authentication, we're going to give this application access to the database ports and the like, but we're not necessarily going to mess with the credentials?
Yeah, so the way I would do that is we have another secrets engine, which we call the KV secrets engine. It's short for the key value secrets engine. I would store my credentials inside of that, and your application would literally reach out every single time and say, read this path, and it will give you those same credentials.
Okay.
The only way that will change is if myself as an operator who is authorized to go into Vault and change that, goes and changes it. But the thing that's nice about that is, you know how we talked about a transit secrets engine that has different versions of a cryptographic key? The same way with the key value store, we've got another secrets engine which is called KVV2. So it's just version 2 of the KV secrets engine. we could store versions of a secret. So if someone were to go in and change that secret, we can reference version 1 and it will still go back in there because it will keep that unless you specify it shouldn't keep previous versions. You can even tell it how many previous versions it should keep. You can even tell it how long it should keep versions for, and it will automatically delete it. But the simplest use case in terms of what you're talking about there, I would store it inside that. I would definitely use version 2 just in case something happens where for some reason you're breached and you need to rotate. And then in terms of dealing with the downtime, because it can always reach back to the previous version, then you've got time to go into your applications and then change which version that is going to for that. It's literally just changing the version and that's it.
So we can use KV as our kind of
Yeah.
our stepping stone, as it were, as we get
Absolutely.
to doing rotating.
I think when we talk about dynamic secrets, that's like the I don't know what the best phrase is, but the holy grail almost, right? That's kind of the destination we want to get to, but it's a journey. So if some parts of your application stack are not ready to go straight into that, then I would definitely say just storing credentials in Vault and using it as a secrets manager rather than an identity broker in that sense is far better than probably anything you're doing at the moment, right?
Oh, absolutely.
Exactly.
It's little steps.
And like this, let me give a straight up example, a very simple example that anyone in networking has done. Your password of last resort, time to rotate it, but 6 months from now, you're gonna run into some box that didn't get hit. And you're gonna be like, okay, how far back is that? Which one is that one? Do I remember that one? What were we memeing on at the time that I deployed this box, right? And instead, I've had to do this. I'd go and Vault. Okay, it's not that one. Okay, what's the previous version? Okay, give me the previous version. Oh, okay, eventually I find my way in, hopefully. But that's why I love that thing, because it's like I don't have to worry that I'm overwriting and losing a password that shouldn't need, but could need down the road.
It's funny, I almost overlooked that part. It's something that, because I'm so used to it, I don't really talk about it that much. It's just a fact of being. But when it's not there, you notice it. You really do notice it. You'll run into those situations. So I'm really pleased to kind of hear you say that you really dig that functionality, because I know I did.